So this is one in a series of Transoft technical webinars. As I just mentioned, it's on data cleansing and deduplication using our DBIntegrate product. This product is kind of like an integration software, and it has a variety of functions available to use in it. Deduplication and cleansing being just two of those. It also provides a migration of data and data synchronization, CEC, just as a brief overview. I am Marion Harrican, and I do the software quality assurance on the product. So I test and I look for bugs, and so I have a lot of experience in using the product on a day-to-day basis. I do regular posts on our developer blog, so please check those out if you'd like to find out more detailing about DBIntegrate and like the latest release notices and so on. And if you have any questions, please don't hesitate to email me. My email address is just displayed on the screen. So just as a brief overview of kind of a few things that we can do with DBIntegrate. Firstly, we can clean data from one source into new tables. So we can split the data using conditional logic such as if statements and else statements. And we can also use an extensive processing function library to help us achieve that. DBIntegrate has a large library of over 150 functions that you can use to do lookups and read data in from SQL databases and so on, and I'll show you a few of those today. You can also produce audit reports, so if you want to do a test run on your data before you do live runs on cleaning your data, that's a really useful tool. And this can show you differences between your source and target data, and what your source data contains and what you want it to be turned into as a way to check and verify what you're doing. And then you can feed back those changes into DBIntegrate before you do a final master run updating your source data. And then the last kind of thing I'm going to show you is merging and deduplicating your data source. So this is the process of looking at your source data and finding your matches and your duplicates using what we call fuzzy matching logic. So firstly, I've got a small data cleansing example, and in this I'm going to do some email address validation. So looking for missing or incomplete domains, or missing @ symbols, or incorrect keys used, and some validation on dates of birth, so dates in different formats or invalid dates and years and so on. And from that I'm going to produce an audit report showing this invalid data and create a suppression list of invalid email addresses, which is quite a popular thing to do with invalid addresses, is to then feed them back into a separate system to make sure that marketing memos and flyers aren't sent to invalid email addresses anymore. And then I'm going to update the source data and do a live run on that data. So this is the DBIntegrate software here, and I've already got a project I've already made. This area here is the area we're going to be focused on, the cleansing job aspect, in which we take our source data and we output it into two audit reports, our audit and our suppression, and then when we do a live run we feed back into this is a SQL database. So we have a tick box option here which we can select to make sure we're not doing a live run. So when I next run this project it will be an audit run. If I open this cleansing job, we open up our data cleansing mapper, and I'll show you some of the data we're going to be looking at. As you can see here, we've got some inconsistencies with the data. We've got email addresses and dates of births mixed up in incorrect columns, and we've got some invalid addresses such as a missing @ symbol, empty data which isn't going to be valid in our scenario, and incorrect domains, like this is missing a .com or a .co.uk, an equal sign here, apostrophes, which is quite a common mistake during data entry when the apostrophe and the @ symbol are on the same key but the shift button doesn't work, or it's set to a different kind of keyboard layout, so it's producing quotation marks, which I've had happen to me in the past. So this is the first table. This is going to produce our audit report. So what I've done here is I've just done some, kind of mapping from this source data to our target, because I don't want to change anything in that field. And then I've done some simple processing here just to put the forename into capital letters. But the interesting stuff here is, we'll look at date of birth first. I've just called a DBIntegrate processing function, and it's going to take this date input I've dragged down, and it's going to return a default value of 1900 by 101 if the date isn't in a format that can be put into a valid date time format using SQL data types. So then that's our way of identifying that that's an invalid date. Depending on what your output is, you could also just put some text as your default value, but I'm just going to leave it as a date for the time being, because when I want to actually audit and update my data, then I'll have to put in a date timestamp. And then here I've got some processing on my email. I've got a function here which checks an email format, which I've just literally dragged down, and then I've applied some conditional processing to say if the email check has returned as false, then just send me a null value, but if it's not false, then return the original email, because in theory it should be a valid email address. On my audit table, I'm also just going to produce an audit timestamp, so say it's been audited by me, MH, and I ran it, and this is DBI now is going to tell us what time it is when I run the function. The suppression list is pretty much the same. It's got a simple reference, and then it's going to use that email check that we've just applied to the audit table and say, well, if it's not false, then skip it, but if it is, concatenate it in within this string here so I can feed this into my suppression system. So I'll show you the output of this. It's just going to give one long string saying Transoft suppression list and then bob@aol.co, because it wouldn't be a valid email address. And then on the update table, which is actually this source table, you can see email list underscore SQL and email list underscore SQL over here. I'm just going to call the outputs of the processing from the audit table, but this won't run during a cleansing audit only run. So this is to make sure that we do all the correct processing that we would want to see, and that our output is going to be what we want before we apply it to the update table. So I'm just going to run this project. The top half of this project is just from my perspective, because I run this a few times, that if I was then to do a live run, the source data would be changed, so I just have to refresh it for just for demo purposes. In a real scenario, you wouldn't have your email data going into your source table again. So if I look at these outputs, I can see I've got 23 records inserted into my email audit cleanse file and 11 records inserted into my suppression file, which is great, but I haven't had any updates or inserts or deletes on the source table because it's an audit only run, so that's a really nice tool to use. And if I show you the source table, you can see it's still the same, it's not had any changes, it's still only 23 records, which is great. If I show you the audit table, for each column that was in the source table, I've added a secondary column called ord hyphen and then the original name of the column, so that I can see the changes that I'm planning on making. So in the name scenarios, I'm just going to put those into capital letters. This is just a simple example. You might not want to do that, but it's just a quick example to show you the kind of things that can be done. And then with the date of birth here, you can see we've got a nice column of formatted dates, but we do have a lot of 1900 0101s, and these all seem to be when the dates are invalid. So we've got an email address there which is not a valid date, we've got a null which isn't valid, incorrect years, and DOB question mark. These are kind of common data entry mistakes that might happen if you don't have validation on your date of births at the moment. And then if I look at email addresses here, I can see we've got some nulls returned here now because they aren't valid emails. Opposed to nulls, you could also put text saying invalid email, or return like a dummy email address or something, or you could even attempt to tidy up some of these email addresses, so put the domain extension of .com on the end, or replace this apostrophe with a @ symbol. But those are kind of things that a human person would really have to look at and kind of define proper data cleansing rules to use for their data to get the result and the output that they want. And you can see I've also just applied some processing which I didn't show you, to take UK and return United Kingdom, and USA to return United States of America, and nulls where the data doesn't match either UK or USA. And I've got my audit timestamp here as well. And if I view the suppression table with our 11 records, this is showing us all the email addresses that we found which are invalid. So we've got blank data here as well, which is to be expected. You could skip those if you wanted as well. I mean, there's not a one-size-fits-all with data cleansing. It's really dependent on what you want to do. And we just got the person ref just for reference, so we know who it is that we're suppressing from the email. It could be the case where you just want to retrieve a list of invalid email addresses so that you can then carry out like a telephone system where you phone all your clients or contacts and say, we've got your email address but it's not valid, so can you tell us what it is, which is a popular output from data cleansing jobs. Now if I go back to properties and I'm going to tick the cleansing live run, then I have to save the job and just run it again using this play icon. So we've got the same output here, apart from now it says live run, so we know that we've actually updated our source table. You can also do deletes and inserts as well, but it's up to the cleansing job you need. And you can see that we've got quite a few blank emails now, blank countries, and our forenames and surnames are all formatted really nicely as well. Now this is a SQL Server table, so just to show you in there as well. You can see we've got our null records and our formats in uppercase and our dates of births as well. So that's a really nice quick data cleansing example. Please let me know if you have any questions at any point, and I'll do my best to answer them. So what I'm going to look at next is cleaning up address data. This is going to extract some postcodes from our address data. In this data we've got quite a few postcodes in incorrect fields or mixed in with other data such as phone numbers, or jumbled up with commas and so on. And I'm also going to do a lookup on a external Excel spreadsheet to return full versions of county names. So within DBIntegrate it is really easy to reference other data sources and retrieve information you want using lookups, which are very similar to a lookup statement in Excel. And I'm also going to remove non-UK addresses from my table. So this is my SQL table, my source table, and as you can see here we've got postcodes in the incorrect columns, and we've got shorthand versions of county names and postcodes all mixed up, and we've got a couple of records from other countries, Ireland, and there's a couple of Australia and Belarus and Germany as well in here. We've also got some postcodes in here in this address 1 column, and you can notice that the address 3 column and building number column are also pretty empty. So what I'm going to do is combine address 2 and address 3 column together and exclude building number column because it is actually totally empty. So here again we've got some more postcodes and so on. This is just a small subset of data of only 997 rows. And what I'm going to do is put it into a separate new table called new address, and this is actually the clean data here, which I'll show you how we achieve that. So I've got address 1, address 2, you can notice that address 3 has now gone, and all our postcodes are all nicely formatted over here, and they've all got a country stamp of the United Kingdom, which they were missing in the previous example. And you can also tell we've got a reduced number of rows, only 769, because we've excluded the non-UK addresses. So if I open up Project Designer and I open up the Address Cleanse project, again the OS and SQL commands, just because I run this project a lot as part of testing, and it's just so that I don't have to continually change the source data all the time. So this is a mapping job in this scenario. I'm not doing the cleanse update on my source table. Sorry about that. So in this scenario, it looks a little bit scary, but it's not too bad. I'm going to take all of the address information, building number, address 1, address 2, address 3, town, county, postcode, and I'm going to put them together into one long string, because we've seen some examples where the postcode was in address 2 and in address 1. So using that long string, I can then use a function called DBI get address postcode and search that whole string and then return a postcode from within that string. I'm then going to check to see if it's a valid geographic UK postcode using some regex in the background, and if this is a correct valid postcode, I'm going to return it in a v_postcode variable, and I'm going to return United Kingdom in a v_country variable, and then I will then call these on the country and postcode fields. So this before step's a really nice way to put your processing all combined all together and then call the variables separately on the columns. And then this last part of the else statement is going to say, well, if it wasn't a valid postcode, just return the original postcode and country, and then if the country doesn't equal to the United Kingdom, then skip the target. So that's how we're excluding our invalid United Kingdom addresses and non-UK addresses as well. Town is just using a very simple processing function to return into capitals. as is address 1. Address 2 is a little bit more complicated. All this processing basically goes to lengths to say if address 3 is empty, then just return address 2, but if address 2 is empty, return address 3. If not, combine them all together and comma separate what was in address 2 and address 3. And there's also a few other checks in there to make sure that the address we are returning isn't the postcode that we've just found in the string as well. So it's finding the postcode and returning it to postcode, but then making sure it doesn't go back into the column it initially was. And then with county, I'm doing a lookup on some external data, and I'm just saying return me the county from the county that I've been given. So Bucks will return Buckinghamshire and Berks will return Berkshire. This is a very specific UK example. You could probably do the same with an external data for states of America and so forth. And DBIntegrate comes with quite a lot of reference data, so country data, county data. I believe this is the data I'm using for my reference, so Berks will return Berkshire, and so on and so forth. So that's the new address column, which will return me this output, which I will show you running in a second. Aside from that, I also have an Excel spreadsheet, postcode underscore audit output, which is going to show me the old address reference, the long string of address that we concatenated earlier, our old postcode, new postcode that we found, a comment just saying postcode found, a timestamp, very similar to what we did in the data cleansing and an audit, apart from it's just been split out into 2 columns. And there's also a check to make sure we're only returning the postcodes that we found within the address data that weren't in the original postcode column. And that's a check to say if the postcode from the source table matches the postcode that we found earlier in the new address mapping, then skip it, because we only want to see the ones that we've identified as being new or invalid previously. So I'll just save that. So if I run this job, we've got 769 records written to our target table, so that excludes the non-UK invalid addresses. So this is the exact same as the one that I showed you in SQL Server earlier, apart from I've refreshed it, rerun it, but it's producing the same results. So our postcodes are nice and tidy, and we've returned some long names where there were short names previously. This example of Hans shows that it's a good idea to do your data and audit it and then go and refine your processing steps. So in this example I could add Hans to my lookup reference table, so that it would find that as a match and then return a long name version in the lookup stage. And now this Excel audit table is interesting because it's only returned 27 records, which is fine, because we can identify that these were 27 records where we didn't have the postcode that was either correct or we didn't know where it was. So if I look at this data, you can see we've got this full address old column. So that's the long string that we concatenated earlier. There wasn't a postcode in the postcode column, so it's going to be empty. And then this is the new postcode that we found. And then to the right of that, we've just got some of our audit data. So we found the postcode, the time and the date, which would be useful if you needed to do long, if you did jobs regularly and you wanted to regularly check the results and find out how well your audit processes were going. And we've got some examples here where the postcode was modelled in with some other data, equals signs and exclamation marks. and domain names, and in this example mixed in with an old phone number, and here as well. So these are kind of common mistakes that can be made in data. So it's really interesting seeing that we didn't have the postcode before, and that we found it before the town in the postcode. Using the asterisks is a simple way I just decided to use, but it's totally up to individuals. You might want to do this on a column by column basis, as I showed you in the data cleansing job of the email addresses earlier. So this is just a way of showing you that you can do it this way as well. It's totally up to you. So that's it with the address cleansing. That was just a really quick, brief overview. That doesn't include things like external raw mail path file validation, which we have access to, but I don't have access to on this machine, unfortunately, so I couldn't show it to you. So you can use that to then verify that the address data that you've got from the postcode is matching each other, and do some next steps verification there as well, building up your mapping job. This was a very quick one. It didn't take very long to produce, so you would probably want to spend a bit more time looking at it. So now I'm going to talk about data deduplication. This is the process, as I mentioned earlier, of finding fuzzy matches and using algorithms in the background to check that your data doesn't have any duplicates within it. So you don't have two John Smiths that both live at number 1 High Street, Langley, and so forth. So we have split this into 4 stages. First we have a normalisation stage, which is putting data into a consistent format to improve matches. And this is pretty much what you would do in a data cleansing job. You would make sure your data is as formatted as possible as well. So in some scenarios, the normalisation step might not be required because you might have just previously undertaken a data cleansing project. The next step is grouping, and this is putting data into sets to look for matches within. So popular groups are country or town, cities, genders. It really depends on your data types. You might want to put people by cost codes or business departments, or even companies that they work for as well, or member data like specific charities that people are working for, and things like that. And then after grouping comes matching. So this is where you do the fuzzy logic to look for your matches. And then you merge your data together. So you either choose a best record, which is a master record, or you choose fields from records to keep as well. So the data deduplication can be quite difficult to discuss. So what I've done is I've taken this small set of data using different variations of my name and different genders. It's something I can easily relate to, and I feel is a lot easier to kind of understand on a smaller set of data level. So as you can see, we've got different variations of my name: Marion, Marion Louise, Marion with an O, and then we've got this other record here, Mary Ann Hunter, who is definitely not me, and we've got a male Martin Harrican, but we also have a female Martin Harrican as well. So we want to identify matches as humans looking at this. So we can easily see Marion Harrican's going to match Marion, and so on and so forth. But it's just about defining matching processing steps so that DBIntegrate or another software program knows how to identify the matches too. So what I've done on the matching step is I've applied some processing functions to look for matches. In this example down here, on the surname, I'm going to look for an exact match. So that's going to compare Harrican to Smith and so on and so forth, depending on what's in your source table. And then that's going to return me a value. And then if that value doesn't equal 30, then I'm going to do a next step matching. So I've called that the second score. So assign a higher score and then a second score and a false score. In this example, I'm going to show you a record needs to match a threshold of 45 in order to be considered a duplicate record, whereas the total optimum number of points they can get is 65. So we could have a surname of score of 30 matching a forename score of 10 and a postcode score to return 45, which would be a match. So if I look at this surname comparison to Harrican, we're calling them match exact first, and then the match Levenstein if it didn't get an exact match, which looks at number of step changes. So as you can see, Harrican matches Harrican, so that's 30. Hurricane doesn't match Harrican as an exact match, so it scores 0 for both of these. And it would require more than 2 step changes to become Harrican, so it gets 0 there. Whereas Hurricane would only require 1 step change, so 1 letter change to become Harrican with an A. So it does get a 20 score here. So it would fall potentially into this match score of second score of 20 plus phone is 10, and then plus an email score, so 20, 10, 15 would be 45. Now this is just this is a simple example. I've tried not to keep it too complicated, but with matching it can be quite difficult to explain what it's doing without confusing people at some point. So I've got 2 examples. Again, I've got here my little table showing the scores that it could get for each of the processing functions I've applied. So Harrican, Hurricane, false, and false again. So it's getting 0 for both of these 2 score options it could have got. The first name has also, the phone number has also failed, so that's getting a score of 0, which is here. So it can either be 10 or 0. The first name result could either be 10 or minus 10, and as it's not matched, it's got a score of minus 10. And the email address as well could also have been a score of 15 or minus 5, and it's got a score of minus 5. And the postcode's got a score of 0 because it didn't match as well. So that's got us a score of minus 15, so that's not a matched record at all. Compared to this example, we've got a couple of true results which have added up to a score of 45. So this is an example where it's failed on the highest score for the surname, but it's passed on the second score for the surname, so it's got 20 points there, and then it's matched on enough high scoring values in order to become a matched record. So I'm going to open this up in DBIntegrate. So this is just an Excel spreadsheet. It's the exact same table that I just showed you in the PowerPoint presentation. And then this is our deduplication job. So here we do a normalisation step, which is putting data into a consistent format. So I'm just doing a couple of DBI to uppers, as it was pretty consistent anyway. With the grouping, I'm grouping by gender, so that's quite important, as it means that Martin Harrican male won't be matched against Martin Harrican of a female, and they've got the same phone number and the same email address. So as a human looking at that, you'd probably think they were the same person, but as we're putting them into different gender groups, then they're not going to be compared against each other. So this Martin record as a male will definitely be in our target data source because it hasn't got any other male records to be compared against. And then on the matching step, this is the match exact and the step change match that we just talked about. So you can see we've assigned a true value of 30 here, and a true value of 20, and the match threshold of 45. You can really just play around with these numbers. You might want to give them an exact match, even a higher score than 30, and you might want your threshold to be higher or lower. There's no exact science of deduplication, so it's just a case of playing around and really seeing what's best for your data. Yep, I can give those questions those slides. And here we've got an email of the DBI match exact not null, which we've given the true value of 15 and the false value of -5. And our postcode as well, value of 5. We haven't assigned any matching to gender or county. And again, that really depends on what you think is important in your data. If you were looking at company data, then addresses might be really very important to you over first name matches or surname matches. And then on this merging step, we've got a forename value, and we're just going to return and say we want to give the highest score to the name that's the longest. So where two records matched and one was Marion and one was Marion Louise, we'd want to return Marion Louise because it's a longer name. So the more data the better. And the same with emails. We had some examples where there wasn't an email, and in some cases there was, so we would want to return an email address record if that was the master record in the match. And same with phone number, county, and so forth. So I'm just going to run this job. This is a nice, very quick one to run. So this is only 4 records that have been returned from our, I think it was 7, yes, from our 7 records. So I'll leave this one up, and I'll just return this one up next to it. So straight away you can see we've got our male Martin Harrican record. And we also have our Mary Ann record, which we knew wasn't going to be matched because it didn't look close enough to anything to do with our matching. Two different between Marion and Mary Ann. And then, as you can see, we've got Marion Louise Hurricane still here in this record because it was too much of an anomaly to match with the Louise part of the forename and the extra length to the surname as well. So that extra E on the end has really made it not become a match. She also happens to be in a different county, but we didn't really do any matching on the county, so that's not a variable that we're going to take into account. And we didn't pay that much close attention to the phone number either. So if we look here, we can see that these 2 records don't exist in our target database, and neither does the Martin Harrican, that's a female record. However, this record does have a phone number which these, the main Marion Harrican record that was returned doesn't have. So what we could do is we could apply some advanced steps to make sure that this phone number is put against this record. If I just open up the job, go to Advanced, we have the option here in Record Creation to choose the Best Fit Record or Best Fit Record fields from sources. If I select that, then it's going and rerun the job. Then it's going to put that phone number against that Marion Harrican record because we're merging our columns together. And here we go. The phone number is now against this record, which is great. Now, what I'm going to do is I'm going to run this job without any grouping assigned to it. So if I delete this grouping, we've got 4 records written at the moment, which should now go down to 3 records. Yes, it has. And you may male Martin Harrican record has also disappeared because it's matched against this master Marion Harrican record. So deduplication, it's really important with this to make sure that you do check your matching and that you check your audit reports to make sure that you're getting really good matches. If I look at this other simple job I've just got really simple matching on just on the surname for a Hamming version of 2, so that's very similar to the Levenstein, just uses a slightly different regex. Going to look for 2-step changes, and then I believe that's the only version. Yeah. So out of all of these columns, I'm only going to match on the surname, which is crazy. If I play this job, then I only get 190 records written out of 887 rows, so that is a phenomenal duplication. I've put on this mapping job at the end, which is looking at our temporary working table to where all the matches and the merge scores are defined. And if I open this up, you can see we've got some matches here. They're in the same match ID group, all of these records, because the name can be changed within 2 steps of each other. So these are exact matches, but Cater and Hamer have been matched against each other. When you can tell that all this other data is totally bogus, shouldn't be matched at all. If I then open that job that I've got pretty identical to, but I've just applied some more matching steps, so on the forename I've done some more matching, on the email I've done some more matching, and if I run this job, you can tell it's taking a bit longer to run now because it's actually going away and doing a bit more matching for the number of rows, but I mean it still goes fairly quick. So just let that just quickly run through. And this time we've got 851 records written to our target, which for a deduplication job sounds a lot more reasonable, and only 71 records written to our audit table. If we look at this now, we can see we've got a lot more sensible matches. Barbara Gavin and Alison Farrow and so on, Simon Wilson and Patricia Cox at Better Projects and P. Fox at Better Projects. They're much more sensible matches as well, so that really shows us the importance of doing good deduplication and not just putting on one function opposed to, as it's quicker, opposed to spending a bit of time running the project a few times to make sure you're getting sensible results. So the next question is there any questions? I had one here earlier, which I've Yep, I can definitely give those slides. And just to let you know that the next webinar is next Wednesday, April the 17th, and it's on how to configure DBIntegrate, change data capture and data synchronization. Brilliant, thank you very much.